So to find the following expression of the integral of cot cubed x dx, we need to set up, first of all, we probably need to split up the identity there. So it might be a good idea to just write cot squared x times by cot x. So this is generally a method we use in order to just deal with more simple expressions rather than, cot cubed x. So if you can simplify it, that's a great way to start. Now, here for cot squared x, I think we should try to use an identity. So what we're going to do is we're going to use the basic identity here that we know of. So sine squared x plus cos squared x gives us 1. And so what we can do is we can actually divide by this expression by sine squared x. So all of these terms here by sine squared x divided again by sine squared x. And the reason for doing this is in order, and you may see it more clearly once we figure out what these expressions simplify down to. So that sine squared x over sine squared x is just 1. Cos squared x over sine squared x, that becomes cot squared x. And 1 divided by sine squared x is cosec squared x. And so this identity is going to be rather important to use in our question. So what we're going to do is probably the integral, where it says cot squared x, I'm just going to transpose this expression. So I'll show you the transposed version. So remember that these two are actually equivalent. I'm going to just write an expression for cot squared x, and we know that that's cosec squared x minus 1. I'm just moving the 1 over to the other side, and so what I'm going to replace here is that cot squared x. I'm just going to replace it with cosec squared x minus 1 times by cot. Okay, so it looks as though we've made things a lot more complicated. And for now, what I would like to do is to expand that cot inwards into the bracket, like so, and therefore have an even more complex equation. It will get better though. I'll show you in a moment what to do. But we're going to get the expression cosec squared x times by cot x minus cot x dx. And then what we're going to do, I'm going to split up the integral into 2 parts. So it's perfectly fine to just split it like so. And that's just to make things easier to calculate eventually. So eventually you will see the purpose of this. Whoops. Okay, computer is not cooperating. Okay, so once we've done that, what we can do now is we should have a think about how we could potentially express cosec squared and cot together. Now we've already done that in when we looked at the identity law, but this is also a very important relationship. It's the fact that when you differentiate the expression cot x, this is something I really recommend you putting into your bound reference. It's equivalent to the negative cosec squared x. So that is an important relationship, because now what you can see is that it's appropriate in this expression, in this first part of the expression here, it's actually a good idea to use substitution method. So what you can do is you can let u be equal to cot x, and therefore you can now go, okay, the integral of u, and we know that du over dx happens to be negative cosec squared x, which actually just becomes these in the form of du. I'll just write the du expression. So I'm just going to rearrange this. I'm going to place the dx on the other side and just rewrite the relationship. So du is equal to, negative du is equal to cosec squared x times by dx. Okay, so getting back to the question. Now, we can see that if we have a look at this cosec squared dx is found in this expression here. Here is cosec squared, and here is the dx, and they're all multiplying. So that part of the expression can actually be replaced by just negative du. So we can just place in the minus du, and then take that u out, and then we still got this minus integral of cot x dx part left over. And so what we'll do now is we're going to clean this expression up. So we're going to take out the negative, like so. And this cot expression, I will expand it into cos x over sine x. Okay, so finally, what we're able to do is we can integrate this part, because this part is in terms of du, so that's fine to integrate. So we just integrate it. Whereas this part of the expression, we may have to do an additional substitution. So for this part of the expression, I would recommend possibly letting u be equal to sine of x. Now, you have to be very careful with what you've made, the u substitution here and what you've made it here. In fact, it may be a better idea, rather than thinking of it as u, to have v, because just to eliminate making mistakes. So I'm going to go dv over dx equals to sine of, no, it doesn't. It equals to cos of x. So we'll write that down. Where is my pen? Okay, cos of x. And then dv equals to cos of x dx. To substitute in dv, we would need to eliminate this part of the expression here. So because they're multiplying, then that's fine. You can go 1 over v and then have dv at the end of the expression. And so now, of course, we'll just write out the expression minus log e of v, and everything's plus c, right? So finally, we need to substitute back what we had made. So we made v equal to sine of x, and we made u equal to cot of x. All right, so we're just going to substitute those expressions back in. We can take the factor of a half on the outside, and then we have cot squared x minus log e of the modulus of sine x plus c. So that is the antiderivative of cot cubed x.